Hi everyone, welcome to today's video where we're tackling a common yet often confusing error in Ethereum smart contract development, the invalid opcode error, especially when you're working with Solidity and ganache-cli. This error can stop your development in its tracks, but don't worry, we're going to break down what it means, why it happens, and most importantly, how to effectively debug and fix it, all in simple terms. First, let's understand what an invalid opcode is. The Ethereum virtual machine, or EVM, executes smart contract bytecode, which is essentially a series of low-level instructions called opcodes, and an invalid opcode error means the EVM encountered an instruction it doesn't recognize or one that's not allowed in the current context, often signaling an underlying problem rather than a literal invalid instruction. Now, why does this happen so frequently with Solidity contracts on ganache-cli? One of the most common reasons is an out-of-gas error. When your transaction runs out of gas during execution, the EVM might throw an invalid opcode instead of a direct out-of-gas message, as it's a way for the EVM to signal an abnormal termination. So always start by checking your gas limits and increasing them if your contract performs complex operations. Another frequent cause is a failed require, assert, or revert statement within your Solidity code. These functions are designed to revert a transaction if a certain condition isn't met, and when such a condition fails, the EVM rolls back the state changes and might report this reversion as an invalid opcode depending on your development environment's interpretation. So carefully review your contract's logic for conditions that might be failing. Less common, but still possible, is a compiler version mismatch. If your smart contract was compiled with a different Solidity version than what your development tools or Ganache are expecting, it could lead to bytecode that the EVM struggles to interpret correctly, so ensure your Pragma Solidity statement aligns with your compiler settings. Furthermore, unhandled exceptions during external contract calls can also trigger this error. If your contract interacts with another contract, and that external call fails or throws an unhandled exception, the error can propagate back as an invalid opcode, emphasizing the need for robust error handling in cross-contract interactions. Finally, sometimes it's as simple as an incorrect deployment or contract address. If you're trying to interact with a contract that hasn't been deployed to the address you're using, or if the address is simply wrong, the EVM will find no valid bytecode to execute, resulting in this error. To debug and fix these issues, you should follow a systematic approach. Begin by increasing your gas limit significantly to rule out gas exhaustion as the primary problem. If the error disappears, you've found your culprit. Next, review all require, assert, and revert statements in your contract and trace their conditions to identify any that might be failing under your test scenario. Utilize a debugger. Tools like Truffle Debugger or Remix Debugger are incredibly powerful for stepping through your transaction and pinpointing the exact line of code where the execution halts. Always verify your Solidity compiler version in your truffleconfig.js or similar configuration file, ensuring it matches your contract's Pragma directive. And finally, double-check all contract addresses to ensure you're interacting with the correct, deployed instance. In essence, an invalid opcode error is often a symptom, pointing to an underlying issue like insufficient gas, a failed conditional check, or a misconfiguration, rather than a literal error in the opcode itself. Don't let it intimidate you. Approach it systematically, and you'll solve it. I hope this detailed breakdown was helpful for understanding and resolving this common smart contract headache. If you found value in this video, please give it a thumbs up and consider subscribing for more content on smart contract development and blockchain technology. Your support really helps the channel grow. Thanks for watching, and I'll see you in the next one.